Durco proudly introduces the Seal Sentry Flow Management System, another milestone in the quest for extended process pump mean time between planned maintenance. This is the Duriron Company's Pump Division Research and Technology Center, the world's leading pump development facility where experienced engineers and marketing specialists work together to solve your process pump fluid handling problems. One such problem is premature seal failure caused by the abrasiveness of solids within process liquids. This problem came into sharp focus in the late 80s after virtually all pump manufacturers responded to customer demands for larger bore seal chambers. These larger chambers were designed to extend mechanical seal MTBPM through improved heat transfer or cooling, and their larger sizes allowed development of larger seals, which could mean extended seal life. But soon, isolated field failures in both straight and tapered oversized bore chambers surfaced. Clearly, the culprit was solids caused erosion of the gland, chamber end, and seals. While this is understandable in straight bore designs, it was believed that tapered bores would not have such a problem. Theoretically, the taper should be self-flushing and self-venting as centrifugal force ejects the solids. However, through testing in the Durco pump lab, we learned that solids actually centrifuge to the bottom of these larger chambers due to the increased circumferential velocity caused by the increased radial distance between the shaft and chamber wall. The resulting high circumferential velocity reduces the axial flow required to adequately flush the sealed chamber. At this point, Durco engineers posed another question. Would the same physical forces that prevent solids disbursement also dynamically entrap vapors and limit heat transfer? Further testing found the answer to be yes. Vapors do continue to centrifuge toward the seal and shaft, contributing to additional problems. Durco now knew that any effort to correct the solids removal problem must also address vapors and heat transfer, and that the resulting product must be thoroughly tested, not rushed to the market. After 3 years of development and testing, Durco found the answer by adding 8 especially designed, tapered and sloped, and strategically placed flow-modifying ridges, or speed bumps, to the seal chamber. The path of process liquid is partially redirected from circumferential to axial flow. The result is reduced circumferential rotation and increased axial movement, which effectively removes solids, expels gases, and improves heat transfer. This concept of flow modification is the heart of Durco's new Seal Sentry family of seal chambers. Their purpose is to extend mechanical seal life. The 5 chamber designs can be modified for jacketed and other special applications to help extend the lives of a large variety of seals from many manufacturers. 3 Seal Sentry designs feature oversized tapered chambers with flow modifiers. Plus, there are 2 cylindrical designs, one oversized and one conventional. Durco lab tests prove that the chamber selection is just as application sensitive as the mechanical seal selection and correlating flush design. A mismatch here may severely limit the ability to extend mechanical seal and seal chamber MTBPM. Another important issue is impeller design. All pump manufacturers design their impellers differently, so each has unique solids and gas removal problems in oversized chambers. Seal chambers from all pump manufacturers experience severe erosion and vapor handling problems in the field. Durco's tests and those conducted independently by Durametallic Corporation verify these problems. We will now show you a series of laboratory tests we think will impress and perhaps surprise you. We have fitted our test pumps with specially designed clear acrylic seal chambers to let you see the movement of solids and vapors in process liquids, with and without flow modifiers. These tests are performed on cool water applications, where process temperature has little effect on the results of aeration shown. Teflon particles are used in some tests to represent solids in the process liquid, and a strobe light is used to allow our video cameras to display the results more clearly. In our first test, we demonstrate a Durco Mark III Group II horizontal ANSI pump with a standard oversized tapered bore chamber. We are using our exclusive reverse vane impeller with standard balance holes. Notice the flow pattern and how some solids remain trapped in the seal face area of the chamber due to the high circumferential flow created by the impeller and large radial clearance between the shaft and chamber wall. Now we slow down the pump to reduce circumferential velocity, but as you see, the solids and vapors remain entrapped. Finally, we remove the solids from the process fluid, but vapors and solids remain entrapped within the seal chamber. Nothing we do to this standard tapered oversized bore chamber will remove the entrapped solids and vapors. The next test demonstrates the same horizontal ANSI pump with a Seal Sentry oversized tapered bore chamber incorporating our FM flow modifier internal design. We again use our reverse vane impeller with standard balance holes. Teflon particles are added to the fluid to simulate process solids. Notice the change in flow from the previous test and how all the solids are effectively processed out of the Seal Sentry chamber. This is because the flow modifiers reduce the circumferential velocity and redirect the flow, thereby increasing the axial velocity. This test demonstrates the original Mark III Group II horizontal ANSI pump with a standard oversized tapered bore chamber. Again, we are using our reverse vane impeller. In these tests, we do not add Teflon particles, so we may more clearly demonstrate aeration. As you see, air pockets are clearly visible around the impeller and within the sealed chamber. Even by slowing the pump speed to reduce air entrapment at the pump inlet and to reduce circumferential chamber velocities, we are unable to eliminate air pockets in the seal chamber, just as Durametallic found in its own recent studies. In fact, Durco's tests confirm Durametallic's findings that under certain process conditions, the chamber and seal faces can be precariously void of liquid, which results in excessive seal face temperatures. Here we once again demonstrate the same Group II pump and reverse vane impeller, but this time we have included our Seal Sentry seal chamber with FM flow modifiers. As you see, although aeration from the suction inlet is clearly visible around the impeller, no vapors exist within the seal chamber. No matter how we adjust the suction pressure to worsen the operating conditions within the pump, we cannot create aeration in the seal chamber. Notice that the addition of Seal Sentry FM flow modifiers eliminates the aeration and air pocket problems in the chamber. The tests you just saw clearly demonstrate how the new Durco Seal Sentry seal chambers reduce solids handling problems and better disperse air and vapors. Durco engineers performed a number of other tests to verify the performance characteristics of the Seal Sentry family. We found that chamber and seal face temperatures are reduced by 10 to 15% due to the improved heat transfer characteristics of the FM design. Although we are justifiably proud of creating the Seal Sentry flow modifying system, we recognize that not all seal applications require a tapered bore with flow modifiers. That's why Seal Sentry is a family of seal chambers that enables you to select the best chamber design for your preferred seal and specific application. That's good news. The even better news is that all 5 Seal Sentry chambers are the same price, because Durco wants you to have the chamber that's exactly right for your needs. After all, we want to be your partner in the never-ending effort to extend process pump mean time between planned maintenance. Get all the details today. Simply contact your local Durco representative.